My name is Mark Lincoln. I work for the Sencha services team, which means basically I'm just like you. I build applications. And some of you in the audience I've had the pleasure to work with to build applications. So even though I work for Sencha, I'm out there in the field building applications, big and small, for clients that Sencha works with. So in my experience, I've seen a lot of different things out in the field, and one of the things I've seen is that we, as application developers, are not taking advantage of all of the possibilities available to us with some of the tools that Sencha is providing, specifically Sencha Command and packages. So that's what I want to talk about today, is how we can be more productive by using Sencha Command and packages to reuse code. Now, the motivation behind all of this is to promote code reuse. We want to be more productive. And as Michael Facemeyer said in his keynote, everything that we're going to be building we're going to have to build better software faster. And so composition, building things with things that already exist, is going to become more and more important. So we need to take advantage of the code we've already written to build the new things that are required by our clients. This is going to make our applications more consistent. It's going to simplify our maintenance. We're going to reduce the amount of code we duplicate. How many of you in the audience have written the same piece of code multiple times in different applications just because you might have not remembered that you built it in this application over here, or you built it for somebody else? How many people have done that? It's a common thing. We want to make the best reuse possible, and Sencha gives us some tools for that. This will make us more productive. And another thing, it will improve our institutional knowledge. As we bring more developers, new developers onto our team, we want them to be able to be as productive as fast as possible. So if we've got reusable code, well-documented code that they can reuse, we can use that to build our applications. Now, we have to decide when we're doing this on a process. And I know most of you probably have a process that you use in your organization to build software. How many people are doing something along the lines of an agile process? Just about most of you. So we want to do this so that we can integrate the process into our existing processes to build software. Now, I'm going to give you a couple options for building your library. The first is building it upfront. And this is sort of an old-style way of building the reusable components. You might design the application and say, okay, we need this particular widget to build our application. So we're going to build that, and then we'll build the application. The other option is to take the code that we already have, refactor that, and bring that into our library, and make our process smarter by taking those pieces of code that we already have and know that work and apply them to future applications. If we do the building of the code for the library prior to building the application, there are some effects to that. We need some requirements. That's typically not how we get things from the people giving the information to us for the products that they need. So we have to work on getting that information from them. That can create a backlog. That can slow down the delivery of the products that we're going to deliver to our clients. So that will cause a delay. And we may have to dedicate some resources to doing this. As I mentioned, this is sort of an old-style way of doing things. The better approach to this is to take the code we already have And I'm assuming everybody in the audience has a lot of code they've already written with XJS. Anybody in the audience brand new to XJS? Just a few. Okay. So we've got some components, some classes, some routines that we can apply to a library and reuse them. This process fits in well with an agile approach. We can include it as part of our project plan, and we can review our code as a regular part of each sprint in an agile process. Now, you may not have the time or the resources to grab the code at that point, but you can mark it and do the process at a subsequent sprint when you can pull that code out and aggregate it into your library. Then you can take and modify the existing applications and build new applications using that library code. Now, resources focused on building your library of code. We typically want to have somebody who's going to be in charge of the library. And for want of a better word, we'll call them the librarian. And their job is to decide what goes into the library versus what doesn't. And you want to set up some rules as to what goes in. For instance, you want to have specific rules on documentation. A piece of code that goes into the library should have some documentation included with it so that somebody who interfaces with that library in the future will be able to know how that code works. There should be a review process, and this would probably be from members of the team that would review the code to decide if it's appropriate to go into the library and if it's been implemented in a way that is ultimately reusable. The librarian, whoever that person or persons might be, are ultimately responsible for including the code in the library. There are some processes that we want to go through to actually do this work, and the tool that we're going to use to do this is Sencha command. So we need to organize the code into logical groupings. We want to create a set of packages, and you may have one package, you may have 30. At the Ask Sencha booth, I saw an implementation where they probably had somewhere 20 plus packages in their implementation. Very good use of packages for code reuse. Now we also need to test the code and be able to retest the code. So we want at least one application that I like to call the proving ground or testbed application, where you run your routines and you're able to test everything and make sure that everything works and that it works together. Now the actual implementation of this process. We're going to use Sencha command, and we're going to want to generate a workspace. Our expectation is that we're going to have multiple packages. We may only have one. We may have multiple test applications, but we're going to start with one. But we want to think forward. And the recommended best practice in all implementations with Sencha command is to create a workspace. So we're going to do that. And I'm going to actually show all of this in an example. Then we're going to generate the packages. Now we've spent a little time looking at our code and identifying the pieces that we're going to put into the library. And we're going to organize that so that we set up our set of packages. In the example I'm going to show you, I've set up 4 packages specifically along functional lines. Now, you may at some point refactor those packages into more specific areas. There are some you may face some things where a particular package is crossing multiple functional lines, but you're using it because you don't have that many routines or classes or components in the library. As it grows, you may want to split it into multiple packages to promote better reuse. And then we're going to generate our application using Sencha generate app that's going to be our test bed or proving ground application. Now the package, a Sencha command package, is really going to be our organizing mechanism. So we're going to take the pieces and we're going to put it into packages, and that will be how we will manage everything. The package will serve a couple of different purposes. One, it organizes the library, but the second thing it does is it makes it easy for the developers on the team to consume the packages in their own application development. You can also use a package to distribute your code throughout an entire organization, and I'm going to talk a little bit about how package repositories work for distribution. The structure of a package, there are specific pieces that go into a package when you generate a package with Sencha command. There are several folders. You may or may not use all of these folders. There's a docs folder that has the documentation you would include with the package. You can provide examples that are package specific. If you are going to license the code to another party, then you would probably want to include some license information. If you need overrides for that package to function properly, they would go in the overrides folder. There's a resources folder where you can put static resources. Many times you'll have an images folder in there that has images that the package uses. Any code, any SAS code required by the package, it would go into the SAS folder. And then the last folder that I'm going to focus specifically on is the source code folder, the SRC folder. And that's going to contain all of the JavaScript source for our package. Now, the most important file for the package is the one that describes the entire package, and that's package.json. That has all of the metadata for the package itself. And currently under Sencha command, you can have three types of packages. You might have already used a theme package. In XJS, the themes are implemented as packages. You can also have a code package or a locale-specific package. The examples I'm going to show are going to concentrate on the code type package. The creator of the package is you or your organization. This is a decision that you'll have to make based on how you are going to work with the package. In an organization, it might be the company name. On my local machine here, I've made it my name, so I am the creator of the packages. You can include some descriptive information, a short description in the summary field, and a detailed long description in the detailed description field. You can also include version information, and you can grab the version of the package in a running XJS application using ext-get-version and passing the name of the package. So that will give you the version information for the package itself. You can also specify the compatibility for your package, and this is important if you've got multiple versions of packages and they have dependencies on other packages. This will ensure that a package that has a dependency is using the right version of the package, especially if it's in a repository. And the last item in the configs for the package is the requires list. And this works just like the requires that you would use for a class in XJS. However, this requires is the list of packages that a package requires. And this is important when building the package. If you leave out a package that another package requires, it's just like leaving out a class out of your requires list in a class definition. The package won't build properly because the required package dependencies are not met. Okay, the way that you want to deal with the packages for distribution or on your local machine is with a repository. The repository is a container that's created by Sencha command, and it's simply a folder that's next to the Sencha command application folder. And the reason it's placed there is if you have multiple versions of command on your machine, which most of us on the services team typically do, they can all access the repository. If it was under a specific version of command, then you'd have multiple repositories depending on version. And this simplifies things quite a bit. Now, this next command here, Sencha repository init, this is important especially if you're going to distribute your packages to other developers. You want to initialize the repository, and this is where you put in the company name or your name. And this name here must match the creator name that was specified in the package. That way the repository knows who the package belongs to. Now, when you install Sencha command on your local machine, it will be initialized to anonymous. If you're never going to distribute the packages to anybody, you can leave it anonymous. And the creator for any package you create is initialized to anonymous as well as the default. But if you're going to distribute them outside of your local machine, you're going to want to give it an actual name. Now, we can add packages to the repository with Sencha package add and giving it the file name. And you have to be explicit here. You have to actually tell it where the PKG file is. Now, the interesting thing about the PKG file, the package file that's generated when you build a package, is it's really just a zip file of the contents of the package itself. And that file will be built in the build folder of the workspace, not within the package. So let's go out here and look at what we've built. All right. Can everybody see that, or do I need to make it bigger? Bigger? All right, we'll make it bigger. Oh, come on. All right, WebStorm is not going to cooperate with me. I don't know why. Come on. It should be Command plus. All right. We're going to have to do with that because Sencha command is not, or WebStorm is not going to cooperate. All right, what we're looking at here is a workspace in WebStorm. And at the top, you'll see the Sencha folder. That's got all the metadata for the workspace. The Aberdeen folder is my testing application. It's my proving ground. And then within that, the workspace, I've got a packages folder. And this is always generated by default. It doesn't have anything in it. And I've got 4 packages in here. I've got an app package, one I called Casino, a common package, and a core package. Now, each of these has dependencies. The core package is the one that has no dependencies at all. And there's my package.json. Maybe I can make that one bigger. Oh, brother. All right, bear with me a second. I'll open it up in a different editor. There we go. All right. So you can see here we've named it SST core, and it's a code package, as all of these are. And I've just given it some descriptive information. And the last part is the most important, the requires. The requires list is empty. So I can build this without any dependencies. My app, you can see the name is different, but if we look down at the requires under this configuration, it has a dependency on core. So the app package requires core to be built for its build. And then if we go to common, Common actually requires both app and core for its build. So we've got a hierarchical set of dependencies here between the packages. So I went through the process of building the packages. Let's make this bigger. There we go. All right. So if we do in Sencha command, if we just do a package list, currently in our local repository, we have SST core, SST common, the ext package, which is always there, and then SST app. So we've got 4 packages. So casino is missing. So let's add casino. So I've already built it. So I need to tell Sencha command where the casino package file is, and it's under my build folder in my workspace in the SST casino folder. So I have to be explicit here. All right, so now it's added the casino package to my local repository, and we can go back and look at the repository again. We can see now we have 5 packages. If I decide that I don't want that package in my repository, I can simply remove it. And removing it, you remove it by name. So I'm going to remove SST Casino from my local repository. And if we go look at the repository again, I'm back to 4. Now, we can also set up remote repositories. There is a Sencha remote repository where you can place your code if you wanted to share it with the community. What is really powerful here is you can set up a repository in your organization that everybody can have access to. Now, the server that would have that repository would simply have the same structure as a local repository, but it has to be placed on a server that provides HTTP GET access. That's it. That's the only requirement. then you can get access to that repository. From your local machine to access that repository, you simply add the repository to your list of repositories that you have access to. And Sencha command, when it's referencing packages, will pull from your workspace first, then your local repository, then the remote repository. So it's going to look everywhere it can to see if it can find the proper code. For that to work, you have to tell Sencha command about remote repositories. So we have to add that with the Sencha repo add or Sencha repository add command. And that will give you access to the remote repository. Now, if we go back to our command line, we can see what I've got access to. And you'll see that I have access to my local repository and that I'm the owner of it because I initialized it with my name. And then a remote repository, which is the Sencha repository. All local repositories have access to the Sencha repository. And then you could add your own organization repository into this list. You can also remove access to it if you decide that you don't want to have access to a particular repository or you've moved the repository to another location. Then you can remove the repository with Sencha repo remove. Now, using the packages, we've identified our code, we've put the code into the packages, and now we want to use them in our applications. We need to build them, and then we can include them in our applications. And there's a bunch of different ways that we can do that. But I'm going to show you one particular way. Now we've got all this reusable code, and I'm going to build a new application. I want to base that new application on my reusable code. So what I'm going to do is I'm going to create an application template. And I've created 2 of them. Now, if you were in the previous session, or you've used Sencha command to generate an application, when you generate an application with Sencha command, you get the boilerplate application provided by default. It uses a border layout, and it displays some basic information, and that's what you get. You can override that capability. There is a switch when creating an application that will allow you to do that. And you have to set up an application template. Now, there is an application template that comes with Sencha command. It is in the plugins folder. If you go to your installed version of Sencha command and scan through the folders, you will find it. It's called Starter App. And that's where all of that structure comes from when you generate an application with Sencha command. Now, what we're going to do is we're going to take the code that's in our library. And there's a bunch of different pieces. I'll quickly go through this. I've got some things like the ability to have configuration settings. So I have a settings class, and that's in my core. And then in my app class, I've got some view controllers. Now, this is a very important point I want to stress. If you're using XJS5 and you're doing MVVM, this is one of the most powerful features, I think, for MVVM. We're very focused on the data binding, but the ability to reuse view controllers and view models is very, very powerful. You can build an entire library of functionality with view controllers and view models and not implement the views. And when you're presented with view requirements, you can pull those controllers into your application, reference them in your views, and you're done. This separates the views from the functionality. The event handling is all in your library, but the views are in your application. It's a very powerful way to implement an application. And then the common, what I've implemented in common are things like a default viewport and a default way to provide login functionality. And since I'm providing login functionality, user authentication, I figured I might as well provide a list of users who could be authenticated in the application. Now, this is boilerplate code. It may or may not be included in your application. It depends on the application you're building. This is all dependent on how your template works. So let's jump back out to our command prompt, and let's go over to a folder that I've created called SST test. And if we look at that folder, you can see that SST test is empty. There's nothing there. No magic, nothing up my sleeves. So we're going to generate a workspace there. And that's going to be our starting point for our new applications. And if we go back over here to my little Commander app, we can see I've got my workspace. And if you've ever generated a workspace, there's not much there. We can look at the packages folder, it's empty. So it's the .sencha folder contains information about that workspace. Now, let's generate. All right, it's a sort of a big, long command, so I'll try to go through the steps here and describe exactly what's going on here. We're going to generate a new application, so we're doing Sencha generate app, and I'm pointing the SDK at a local folder so that we don't have to download it from the remote server. And then you'll see, and it's sort of hidden. Let's see if I can see this little S right here. That's our starter app switch. You can also do -starter app. And we're going to point it at our first starter app in the repository. And we're going to call that application Aberdeen. And then we're going to put it in the Aberdeen folder in our test workspace. So let's generate that. It'll take a second to copy the local copy of ext. Now, what it's doing here is really important. It noticed that my template application that I'm generating is dependent on packages. SST core, SST app, and SST common. So it's going to grab them as well out of the local repository and bring them in. So if we go back and look at our structure here, we'll notice that our packages folder now has 3 packages in it. They were grabbed from the local repository and brought down into the workspace. Now, I can go over to my browser. Let me refresh it. And there's my application. Doesn't look anything like the starter app that comes with Sencha Command. It's all based on the functionality in the library. We now have a login, and I've defaulted the username and password through configurations so that I don't have to type them in. So I can click my login, and you'll notice as soon as I logged in, I got a button over there for my users, and I can see the list of users of the application. I can also log out of the application. All of this functionality is now boilerplate. If we go back and look at our packages, and we take a look at our template, we can see here we've got a view defined, and that's my viewport. The viewport here in main.js default, that template is extending, and you can see here, oops, wrong button. You can see here that it's extending SST main viewport. That's coming out of the library. Now, when I was doing the Ask Sencha yesterday, I was presented with something interesting, an application that had no functionality at all. All of the functionality in packages. I thought that was interesting. And so I created a template, and you'll notice my view folder has nothing in it. I have no main view. So what's going on here is if we look at app.js TPL for our starter app, you'll see now here SST main viewport is our auto-created viewport. So if we go back out to command, this is a very similar command to the one we just ran on to generate the first template application based on the packages, except a couple things have changed. We now are using starter app empty rather than starter app because it has no main view. And we're going to generate Aberdeen empty in the Aberdeen empty folder in our workspace. Now, some interesting things to note here. It didn't do anything with the packages. And the reason for that is the packages are already there. Sencha Command discovered them within our workspace. So it doesn't need to know that it doesn't need to grab them from the local repository. They're already there. So it simply had to generate the application. So if we go back out and look at our workspace again, we've now got an Aberdeen empty application. And if we look in the view folder for the generated application, it's empty. Nothing there. So if we jump over to our browser, let me refresh that. Same functionality. So now the main view of the application is not even in the application itself. It's sitting in the package. So we can implement the entire functionality of an application outside of app.js and application.js in packages. And if we test this, same application. So in one, we extended the viewport in the package library, and in the second, we actually just used the boilerplate viewport. Now, in dealing with an application that's using packages like this, there are a couple management issues you want to be aware of. First, putting code into a package repository is not a version control system. You still need to manage your code within Git or Subversion or whatever your version control system of choice is. Also, when you place packages into a repository and say, you update one of the packages and I'm building an application depending on your packages, I will not know that you've changed the package. However, Sencha command, if you use it, will periodically check to see if the metadata of a package locally matches the metadata of a package in the repository. If it doesn't, then it will refresh the package locally. You can force that by using Sencha app refresh -package. That will force a refresh of all of the packages that an app depends on. If you've got multiple apps in your workspace and they all depend on the same set of packages, then you only have to do the refresh in one of the apps. All the packages will be updated and all of the apps will know about the update. Okay, any questions about this?
All right, so we have used packages in our projects, and we have achieved this kind of sharing, and it's really kind of cool. But we have done this in the outside of Sencha Architect, right? So for projects just using Sencha command, we've done this. I'm not a heavy Sencha Architect user, but I believe there's the same concept in Sencha Architect as well. We are looking to extend the sharing, between, for packages created outside of Sencha Architect and being used in Sencha Architect. I think you can do this currently using user extension. However, you still have to hand code a bunch of architect files to be able to, kind of share your extension or your packages that was created outside of Sencha Architect to be able to be used to Sencha Architect. Are there any plans to kind of bridge the gap? Or are there any tools that we can use to kind of generate this, metadata?
I don't know if there are any current plans to bridge that so that it's more usable in Sencha Architect. And I don't know of any particular way to solve that on your own. That is a challenge. One of the areas that you can attack the problem is by using the mix-in capability with Architect, but that doesn't specifically address the package issue. So at this point, there isn't a boilerplate solution for that problem.
One last question. What's the difference between .pkj and AUX?
Between what?
The .AUX for Sencha Architect and PKJ, is it the same thing? Is it the same zip file?
I didn't really understand.
The user extension when you want to use in Sencha Architect, I think it is .AUX.
The Architect user extension.
Is it the same as the PKJ? or is it different?
It's different.
Okay.
Yeah.
Thank you.
Short question. If I have multiple applications in the same workspace, can they use different versions of the same package?
Different. You didn't need to have the versions. You can have multiple versions in the repository.
Yeah,
Yes.
so I can specify this application uses a version 1 of the package, and another application uses version 2.
Yes.
In the same workspace.
Yes, you can.
Okay.
Yeah, that's the compatibility version, and there are switches, and I should mention this. There are several guides on this subject. There's one on Sencha command packages, and there is one on creating Sencha command packages. And then a lot of the information is also, if you study the command reference, there's a lot of information in there as well that will describe how all of this works.
So in example, you're showing to getting package from a remote repository. So at an enterprise level, what's required to creating this remote repository? I said in example, you're showing how to getting the remote package from a Sencha repository. But if at enterprise level, we want to share package across multiple teams, what is it required to creating this remote repository for package? Is this something you have to do on the server side to create structure, or how does it work?
The easiest way to do that is to take the package folder from your local repository and put it onto a server that has HTTP GET access. Any local repository can be a remote repository.
So we're using like a SVN and TFS for storing all the source code. So if we put the code into TFS, let's say, when user check out with the same structure, with this automatic share with the local package repository?
I think what you're saying is you've got it into TFS, into your version control system.
Right.
And when you check it out of there, are you checking in the package itself, or
checking package itself?
Okay.
Is that a way to share the package with the enterprise, or you have to creating a separate server for the share?
Well, you sort of have to decide if you want your version control system to manage that within your workspace.
Right.
That may be the easier way to go rather than using a package repository per se.
I see. So as long as when you check out this package into a certain directory structure, then it's reusable across our project.
Yeah.
Okay. All right. Thank you.
Time for one more?
Yes, absolutely.
That's smart. Why not just use Maven? Or can you point this at a Maven repository and have it pulled down for a remote repository?
Rather than the Sencha command repository?
Well, yeah. I mean, we use Artifactory for all of our Java dependencies and all the rest of this stuff, and it would be really nice if we could point command to pull down from there instead of having a separate structure to store these packages.
Currently, we don't support that. You can ask, put in a feature request since command is written in Java, and there are some options there.
Okay.
But right now, it's not a capability.
Yeah, I was wondering if there's something I could do with Maven to force it basically to look like an HTTP GET. So.
There may be. I'm not an expert in Maven, so that's sort of outside of my wheelhouse.
Cool. Thanks.
Oops. Are there any other questions? If not, thank you.